Alright guys, this is 12.4 Trig Applications. So today we're going to use what we've learned in order to solve some real life problems that we could run into, okay? Please do your best to get this. Do not skip this. We're also going to do, most likely, do an activity after this where we'll go outside and use trigonometry in the real world, okay? All right, so here we go. First thing we need to talk about is two vocab words. One is the angle of elevation and the angle of depression, okay? So oftentimes they're going to ask you that. So like for example, number one, it says a tree has a shadow that is 16.5 feet long. If the angle of elevation from the end of the shadow to the top of the tree is 58 degrees, how tall is the tree? Okay, so here we have this word angle of elevation. You'll also see ones where maybe they'll ask you to find that angle of elevation or depression. Okay, so let's make sure we understand where that's coming from. So let's come up with an example. This is maybe Mr. Warner. I'm up here, and maybe this is you. You're down there, okay? Or vice versa, it doesn't matter. I can be low and you can be high. All right, but if you were looking up at me, okay, normally would maybe look straight across, right? But maybe now you're looking up at me. That is called the angle of elevation. You have to elevate your eyes to look up, okay? Here, if I was looking down at you, normally I look straight across, but now I have to lower my head to look down at you. This is what's called the angle of depression. Okay? You're looking down. All right? So if we looked at those two angles, do you notice anything about those two angles? We didn't really talk about this when we did triangle similarity, but if you ever have two parallel lines and then you have a transversal or a line that cuts those two parallel lines, then we end up getting that they're called alternate interior angles. Alternate meaning they're on the opposite sides of that transversal, that line that cuts between. So opposite side, but interior of those parallel lines. So alternate interior angles, those are congruent, or they're equal, they're the same. So same thing here. We have, this would be parallel to this line. We have a transversal, okay, which means that the angle of depression and the angle of elevation are the same, okay? Their value, like if this was, 40 degrees, then this would also be 40 degrees, if I can even write it, okay? Those would be the same angles. All right, so whenever you're like sketching the situation, it doesn't really matter whether or not they're asking for angle of depression or elevation because they're the same number, okay? But what you do need to realize is that angle is always the side of the triangle that is horizontal and the hypotenuse, okay? We'll never have this. This is never the angle of depression, okay? Never, never, ever. All right, it's always the horizontal and the hypotenuse, so I have that written here, okay? All right, so remember, the best way to tackle a word problem is to sketch it. Okay, so please, that'll be part of your problems on your homework and on your test, is to first sketch the situation. So here, we already read this one, but let's give it a try. It says a tree has a shadow that is 16.5 feet long. So here's my tree. Here's its shadow. And it says this is 16.5 feet. All right, if the angle of elevation from the end of the shadow to the top of the tree, so we have this angle here, and it says angle of elevation. So again, it's always the horizontal and the hypotenuse. Okay, is 58 degrees. How tall is the shadow? Or the tree, sorry. How tall is the tree? So this now, we've sketched the situation. It looks very similar to the types of problems that we did previously. Okay, so do the same thing that we did last time. Well, we'd want to label our sides. This would be our H, this would be our O and our A. What's given is A, what we're looking for is O. So what uses O and A? Well, that's tangent. So tangent of 58 is equal to O over A, x over 16.5. And then we got to get x by itself, so we just multiply both sides by 16.5, and we'll type it into our calculator. 16.5 tangent of 58. So I end up getting x equals 26.4 if I round to the tenths place. And this is feet. Okay, so use units if units are given. All right, so let's do a couple more. Looks like we have 3 more. You feel free to pause any of these and give them a try. See if you can sketch the situation. All right, so a meteorologist reads a radio signal to get information from a weather balloon. So here's my weather balloon. Okay. It says the last alert indicated the angle of depression to the weather balloon. Sorry, did I miss part of that? The last alert indicated that the angle of depression of the weather balloon to the meteorologist was 41 degrees. So again, if we're talking about angle of depression, it's going to be something like this. But if you were to draw your balloon like this, or your triangle like this, again, this is the angle of depression, this would be the angle of elevation. They're the same, so you could draw it either way, it'd be good. Okay, so this would be 41 degrees, or this would be 41 degrees. Okay, so it just depends on how you draw that. Okay, so anyways, back to that. Angle of depression was 41 degrees, and the balloon was 1,810 meters away from his location on the diagonal. So diagonal would be like the hypotenuse. So this would be 1,810 meters. Okay. To the nearest meter, how high is the balloon, or above the ground is the balloon? So they want us to know this location. So again, you can put it the order however you want your triangle. Again, it's going to always be a right triangle. We're always going to have, like, the legs of the triangle will be, like, vertical and horizontal. Okay. All right, so now we just need to figure out what H is. Let's label our sides. So this would be our hypotenuse, that's our right. And this would be our opposite. Same thing here. If you look at the other example, this would be H and this would be O. So we'll use sine. So that's so sine of 41 is equal to, okay, I'll zoom in a little bit, sorry, O over H. And H is 1,810. So to get x by itself, you know what to do. And then we'll type that into our calculator. So 1810 sine 41, enter. So I end up getting x is 1,187.5. I don't know if it says round, but if it doesn't ask you to, like, what to round to, just always round to the tenths place. And this is meters. All right, the next two are a little different. For these ones, they're going to ask for the angle of elevation or depression. So here we have an 18-foot ladder rest against the wall. So here's my wall. Here's my grass. Here's my ladder. Okay, and it said it's an 18-foot ladder. The base of the ladder is 6 feet from the wall. So the base would be where it touches the ground. It says it's 6 feet from the wall. So what angle does the ladder make with the ground? So the angle where it touches the ground, that would be like our theta. That's what we're looking for. So this is going back to like lesson 12, sorry, 12.2. So we label our sides. This is our H. This is our O. This is our A. We have our H. We have our H and A, but we need to find our angle. So what uses A and H? Well, that's cosine of theta is A over H, and we need to solve for theta. So we use the inverse. So how to get theta by itself is we do the opposite of cosine is cosine inverse. And we get theta equals, again we'll do like shift or second cosine to get cosine inverse, 6 divided by 18. And I got 70.5 degrees. Okay. Last one, a diver wants to visit a shipwreck. Okay, that is 650 feet below the water. So here's my water. Here's my shipwreck down here. It's all broken, okay, but it says it's 650 feet below the water. There's too much danger to start diving directly above the wreck. So the diver jumps from the boat and swims diagonally. So the boat where he gets out can't be there. It's too dangerous. So the boat's over here, and he swims diagonally to the shipwreck. And it says it's 935 feet. All right, so what is the angle of depression? So angle of depression, again, it's always the angle made by the horizontal and the hypotenuse. So now we can label our sides. We're trying to find that angle. So we have H, O, and A. Okay. And we have our O and H, so that uses sine. So sine of theta is equal to O over H. And then we need to get theta by itself. So we'd use sine inverse to get theta by itself. So second sine, 650 divided by 935. And I got theta equals 44.0 degrees. All right. So again, hint, always sketch the situation. You'll always have a triangle that either looks like this or like this, depending on how you maybe want to do it. We'll always have, the hypotenuse is always the longest side. This would be like this would be our angle of depression. This would be our angle of elevation. Again, they're the same. We have our heights. We have our distance. Okay. So always just start by sketching the situation you think that would match, and then find the missing information. All right. Let me know if you have any questions, or if you have problems with your calculator being in the right mode. Let me know. All right. We'll see you.